Welcome to Spring LIB.
In this problem, on the topic of kinetics of a particle, we are given the rate at which the arm in the diagram is rotating, and we know the angular acceleration and the angle theta. We then must determine the force that it is exerting on the smooth cylinder if it is confined to move along the slotted path, and we assume that motion occurs in the horizontal plane. Now, we can see here that r is equal to 2 over theta, which means that dr d theta is equal to minus 2 over theta squared. Now, the angle psi between the extended radial line and the tangent can be determined as follows. Tan of psi is equal to r over dr d theta, which from above is simply 2 over theta divided by minus 2 over theta squared. And so this simplifies to minus theta. Now, we know at theta is equal to 180 degrees, which is pi radians. The tan of psi is equal to minus pi, which gives us psi to be minus 72.34 degrees. Now, the negative sign here indicates that psi is measured from the extended radial line in the negative sense of theta, which is clockwise to the tangent. So if we look at the full body diagram of the peg, as shown in the figure below, then we can apply Newton's second law as follows. So if we take the sum of the radial forces, this must equal to the mass of the peg m times the radial acceleration ar. And from here we can see that minus n sine of 72.34 degrees must equal to 0.5 ar. Similarly, the sum of all the angular forces F theta is equal to m times a theta. And so from here we can see that this along the theta axis is F minus n times the cosine of 72.34 degrees, and this is equal to 0.5 a theta. So now if we use kinematics and use the chain rule for the first and second derivatives, or first and second time derivatives of r, we get, firstly, we know that r is 2 theta to the minus 1. So the r dt, which is r dot, is simply minus 2 theta to the minus 2 times theta dot, which is minus 2 by theta squared theta dot. And the second derivative of r with time r double dot is minus 2 into minus 2 theta to the minus 3 times theta dot squared plus theta to the minus 2 times theta double dot. And so this simplifies to 2 over theta cubed into 2 theta dot squared minus theta double dot. Now, when the angle theta is equal to 180 degrees, which we said is pi radians, then we have theta dot to be 4 radians per second, as given in the problem statement. And we also have theta double dot to be 3 radians per second squared. And so, therefore, we can see that r is 2 over pi meters, which is simply 0.6366 meters. R dot is minus 2 over pi squared times 4, which gives us minus 0.8106 meters per second. And r double dot is 2 over pi cubed into 2 times 4 squared minus pi times 3, which gives us the acceleration r double dot to be 1.4562 meters per square second. So therefore we can find the radial and angular acceleration. So AR is equal to r double dot minus r theta dot squared, and now we can just substitute the values into this, which becomes 1.4562 minus 0.6366 multiplied by 4 squared, which gives us a radial acceleration of minus 8.7297 meters per square second. The angular acceleration, a theta, is r theta double dot plus 2 r dot theta dot. Again, we can substitute values into this. That's 0.6366 multiplied by 3 plus 2 into minus 0.8106 times 4, which gives us the angular acceleration to be minus 4.5747 meters per square second. So if we substitute these into our equations from Newton's second law, we get the force N to be 4.5807 newtons and the force F to be minus 0.898 newtons. Now the negative sign here indicates that F acts in the sense opposite to that shown in the free body diagram.